Okay, so for this example, we're focusing on step 2, which is essentially you've converted your integral in terms of x and dx into a trig integral in terms of theta and d theta, and now we're focusing on integrating that trig integral. So let's look at this first step. The first example that we have here, it turns out to actually be the first example that we did before. So I can go ahead and borrow my results from over here. So let me just copy and paste. Okay. And so what I need to do for this problem is essentially evaluate that trig integral. So the trig integral that I have here is, let's see here. The trig integral that I have here is 1/9 integral of cosecant squared theta d theta. So this is a trig integral. But this is a
It's
really
1745.
Sorry. This is a really easy integral because it's going to just be negative cotan of theta, right? So don't forget your table of basic integrals, because instead of scratching your head trying to figure out how to integrate this, it's on your table of basic integrals, okay? So we're done. This would be step 2, right? So step 1 is converting what's given into a trig integral. And then step 2 is evaluating the trig integral. We could put plus c, right? And then step 3, of course, is to translate your answer, right? Put your answer back in terms of x. And you use the triangle to figure out what's the relationship between theta and x and back substitute. Let's go ahead and do another example here. Now for this one, I'm going to quickly, and then the keyword here is quickly, set up the appropriate right triangle. I'm just going to do it. I'm not going to rush through it, but I just kind of want to give you an idea of, time-wise, how it can be if you're not, after you've practiced a little bit and you're not explaining each step, right? So kind of what would I expect to see in terms of working on an exam set. Okay, so I'm just going to kind of talk out loud to myself here. So I see down here, first thing is I've got this 1 over x squared plus 1 to the 3 halves. I recognize that as the square root of x squared plus 1 over 1, and then that's cubed. So I'm going to use square root of x squared plus 1 as the hypotenuse in my triangle. Okay. So this is going to be square root of x squared plus 1. So a leg must be x, and another leg must be 1. And I'll put my theta down here just to make life easier. Okie dokie. So the relationship between sine or x and theta, I need, let me just go straight to tangent of theta equals 1 over the square root of x squared plus 1. So that means 1 over x squared plus 1 to the 3 halves is going to be tangent cubed theta. And what about dx? Because that's the other thing I need to translate. Now to get dx, I'm going to use cotangent of theta. That's going to be x over 1. Wait. Tan of theta is 1 over x. What I want is sine of theta, which is opposite over hypotenuse. So let me start over. So I actually caught myself because cotangent of theta should be the reciprocal of tangent of theta. So let's go back. Okay. So now 1 over the square root of x squared plus 1 is going to be sine of theta. So sine of theta is 1 over the square root of x squared plus 1. So 1 over x squared plus 1 to the 3 halves is going to be sine cubed of theta. Okay, and now to get x, cotangent of theta is x over 1. So then dx is, what is the derivative of cotangent? The derivative of cotangent of theta, I believe it's negative secant theta. Let me just verify that. Yes, negative cosecant squared theta, sorry. Negative cosecant squared theta d theta. All right. So I've got dx over x squared plus 1 to the 3/2 is equal to the integral of negative sine cubed theta cosecant squared theta d theta. Okay. And sine, cosecant is the same as, let's see here, cosecant theta is the same as 1 over sine squared theta, cosecant squared. So, oh, this is good. Things are going to cancel out. This is going to be fun because the sine squared and the sine cubed are going to cancel out, and I'm just going to be left with the integral of sine theta d theta, which is going to be negative cosine theta plus a constant. But I've got that negative, so the negatives cancel out, and I just have cosine theta plus c. Ugh, that was horrible. There we go. Okay, so this is my step 2, is to evaluate this trig integral. So this trig integral wasn't that bad because, it doesn't rise to the level of the integrals that we were doing in the last section, like secant cubed, tan squared, and, stuff like that. So this problem wasn't that bad.